Hi guys, I'm back. So in our last video we did elements, compounds and mixtures. Just to recap though, we said that elements are substances which has only one type of atom, and we looked at the periodic table. Remember, hydrogen, helium, lithium, beryllium, boron, carbon, all those are elements. All right, we said that these are substances with only one type of atom. And we spoke about compounds as well. We said that compounds are formed when two or more elements come together to make something. So for example, if hydrogen and oxygen come together to form a compound, the compound is water, right? This new substance, it retains or it has a new property. It does not have properties of hydrogen or oxygen differently. We mentioned too that mixtures are substances. They are physically combined, and when they are physically combined, they can only be separated by physical means. And we spoke about sugar and water, salt and water as mixtures. So in this lesson, we'll be talking about the types of mixtures, and there are two types of mixtures. We have homogeneous mixtures and heterogeneous mixtures. Growing up, we learned that the prefix homo means the same and the prefix hetero means different. So homogeneous mixtures are mixtures in which the particles are evenly distributed throughout. This means that when you look at a homogeneous mixture, you do not see particles standing out separately from the solvent, right? And at this stage, you should know that a solvent is anything that a solute is dissolved into. All right, so we talk about heterogeneous mixtures, and hetero meaning different, meaning that the particle size are not distributed evenly, right? So looking at a heterogeneous mixture, we can see the particles differently. Some would be at the top, for example, in oil and water, and some would be at the bottom, for example, in sand and water. We also have substances that are called colloids, right? Colloids are between homogeneous mixtures and heterogeneous mixtures. So they would fall right here, right? Homogeneous mixtures are normally solutions. Back to homogeneous mixtures. When we mix salt with water, as you will see in a demonstration later, we will realize that we cannot look at the salt particles to say that this water has salt. When we mix alcohol with water, we cannot see alcohol, and in this case, the water is the solvent and the alcohol is the solute, because the greater proportion is the water, right? Mixing sugar and water too, we would see that we cannot see the sugar crystals, but what we see is that the water changes color. If it is brown sugar, the water changes color. If it's white sugar, then there is no changes. This means that the particles of the salt and sugar, they are evenly distributed throughout. So we look at that as solutions, right? We do not call heterogeneous, we don't call it solutions, because the particles are not completely dissolved. We call them suspensions. So guys, I'll be demonstrating to you homogeneous and heterogeneous substances, or mixtures actually. All right, so here is water, and here I have brown sugar. I'll be dissolving the sugar for you. We see where the crystals are dissolving. And the reason they are dissolving slowly is because I'm using room temperature water. If I was using warm water, they would have been completely dissolved already. So the temperature at which sugar crystals dissolve have an effect on the rate at which it dissolves. You can hear the breeze blowing off my stuff. All right, now I have another container. I'm gonna put some salt in. Vigorous mixing. So vigorous mixing will allow the salt crystals to dissolve faster. Alright guys, so I'm gonna put this salt water right there and my sugar and water right here. Now guys, I have water. As you see, I'm gonna add some syrup to it. I love science. I live science, my life is science. Alright guys, so syrup and water is a homogeneous mixture. As you can see, you can't see any particles in the syrup and water. Only thing that changes is the color of the water. There are no crystals in this. And as you see, this is what the container we added the salt to, sodium chloride, which is a compound. It is NaCl. We realize that there is just water. We cannot see the salt crystals. This is our sugar and water. This is a solution. We cannot see the sugar crystals because it has been completely dissolved. So all these three are examples of homogeneous mixtures. We have sugar and water, syrup and water, salt and water. So this is sand. I'm going to pour some in water. I will let it stand out for a while. Here I have some cooking oil. I'll be adding some water to it. As we can see that the oil is not dissolved in the water. We can see the water separating from the oil. This is an immiscible substance, meaning it's not miscible. The particles do not join. With the sand and water, we can see where the water is on top and the sand particles are at the bottom. This is called a suspension, and it is a heterogeneous mixture.